Okay, we have finished 1/4 of the course, or we will have finished 1/4 of the course by the end of class today. In intermediate algebra, there are 4 families of functions that you'll be held responsible for. The first one is linear functions, which we will wrap up today. At some point of time in the near future, we'll start with quadratic functions. Then we'll head over to rational functions. And then at the end of the course, we'll finish with rational functions, or radical functions, rather. So that's overview of where we are and where we need to get to. This is going to hopefully seem familiar, but this is all the new stuff I'm teaching you today. Everything we have done up until now has led us to solving for the equation of a straight line in slope-intercept form. Yes? So that was a linear equation. Linear equations are in the form y equals mx plus b. Are we okay with that? Nothing new there? The only new thing I'm showing you today is just the relabel job. We have something called function notation. I'm not telling you what a function is. That will come later. But all I'm saying today is y can be rewritten or replaced by f of x. This is not f times x. You're not multiplying f by x. All you're saying is f is a function of x. A function is just a machine. It eats something and then it poops something out. I'll be a function. Give me a number and I'll give you back something in return. So someone, give me a number. I'll start with 5. The answer is 1. Give me another number. 5 went to 1. 6 goes to 2. Give me another number. 3 goes to -1. Give me another number. 8 goes to 4. Give me a challenge. Come on. 16 goes to 12. What was it? 20, 23 goes to 19. What function am I? What am I doing to your input and spitting something back? Subtracting 4. So the function I am is x minus 4. You give me an x value, what do I do to it or with it? -4, and then I give you that back as an output. That's all a function is. It eats an input, poops out an output. That's it. It's an input-output machine. Fair? Isn't that what this linear equation is? Don't you plug in x values and get y values back? All we're doing today is rewriting something as an that was an equation as a function. Are we okay with this so far? Nothing revolutionary yet? Have we done this question before? Find the equation of a line with a slope of 6 with a y-intercept of 0, 4. If I gave you a slope and I gave you a y-intercept, can we come up with the equation y equals 6x plus 4? The m is 6, so I replace m with 6. The b is 4, so I replace b with 4. And there's my equation. We've done this before, yes? Nothing new here. Have we also graphed the equation using the y-intercept and the slope? So you would go up 6 and over 1. What will be the new coordinates of that point? If I start at 0, 4 and I go up 6 and right 1. 110, because I moved right by 1 and I moved up by 6 from 4. Fair? So there. Could we have been given a point and a slope and I ask you to come up with the equation? Then we do that Monday and Wednesday and also Friday to some extent. Then didn't we talk about graphing straight lines using 3 different ways? X-intercept, y-intercept, finding any 2 random points, and using the slope and the y-intercept. So we found the graphs of straight lines as well. We've also found the equations of straight lines. Y equals 6x plus 4. Here's the only thing that's new today. That is the answer in function notation. F of x equals 6x plus 4. Give me a number, any number you like. Small number. 8? Okay. 8 means plug in 8 for x. 6 times 8 is 48 plus 4 is 52. Isn't this what we've done before? Find the value of the dependent variable when the independent variable is 8. Didn't we plug in 8 for x and find y, which was 52? Yes, no? Nothing new is happening today. I'm just doing a relabeling job the entire time. Now, why do we need to do this? In this equation, y equals 6x plus 4, what is the independent variable here? What's the dependent variable? Sorry? No, right here. Y is the dependent variable because it's by itself. X is the independent variable because it's with the other stuff. Yes? What's the independent variable here? How do you know? How do you know? No, no, no. Why? Dang it. You shouldn't have seen that. Okay, imagine you didn't see that. From this, what's the dependent variable? You have no idea. Do we know what the independent variable is? Also, no, you have no idea. Do we understand why this is bad writing, mathematically speaking? It's not in slope-intercept form, fine, but which variable would you isolate? Do you isolate P or do you isolate Q? Exactly my point. You have no idea. When we have X's and Y's, don't we know the Y goes by itself? When you have P's and Q's and A's and B's and R's and S's and C's and D's, do you know which variable goes by itself? Which is why we move away from this into function notation. Okay. The thing on the outside is always the dependent variable. So there's never any doubt about who is dependent and who is independent. The independent variable is always inside parentheses. Always. Doesn't matter where you are in the world, the independent variable is always going to be the guy inside parentheses. So look up here. What's the independent variable? How do we know? Because it's in parentheses. Do I have to even look at this side at all? Do I have to look at the function at all? Nope. The function notation tells you everything you need to know about this. X is inside the parentheses, so X is the independent variable. What's outside the parentheses? So that's the... Does that make sense? Do we see why this is noticeably superior to just writing X's and Y's all over the place? Here, do we know who the dependent is and who the independent is? No idea, because I have no clue. Here, who's on the outside? So who's the dependent variable? P, because it's on the outside. Who's the independent variable? Because it's where? Does that make sense? It should be morbidly obvious. The thing on the inside is the independent variable. Thing on the outside is the dependent variable. Yes, no, maybe so. Isn't this question one we've done before? Write a linear equation in slope-intercept form passing through 1, 2 with a slope of 3. How would we do this? I did this on Wednesday or maybe on Monday as well. It's the go-to example. Easy numbers, easy equation to come up with. How would we do it? Let me write down the equation first. Y equals mx plus b. And now what are we doing? What about the point as well? Are we all okay with that? Do we recognize that the x coordinate is 1, the y coordinate is 2, the slope is 3, so I plug those three numbers where they belong, and b is left alone because I don't know what the y-intercept is. The question didn't tell me that. But can I find b from this? I can. 3 times 1 is... How would we get b by itself now? Subtract 3, 2 minus 3 equals b, so b is what? I don't want to go too far down. I don't want to show you what's next. Are we okay with this? Again, this is all stuff hopefully we've done before and is very, very recognizable to you all. So based on just this, what would the equation of the line be? Y equals what? This is the equation of a line in slope-intercept form. Isn't this stuff we've done before? Here's the new thing. What if I take this away and go back to the original question? Write a linear function, excuse me, passing through 1, 2 with a slope of 3. Would you do anything different from what I've already done in red? How would you answer this question at the end? Instead of y, what would you write? It's just a relabeling job. The math doesn't change. All you're doing is saying, hey, that equation nonsense, very bad. Because I don't know which equation we're talking about. It's very poorly organized. Half the time we don't know what the dependent variable is. We don't know what the independent variable is. Function notation removes all doubt. Are we okay with this? So again, nothing new is being taught. It's just relabeling stuff we've done before and formalizing all of it together. Six functions in front of us. Top left, let's go one by one. 3x squared plus 4. Is that a linear function? What's a linear function? It's got to look like a straight line. Y equals mx plus b. Does this guy look like mx plus b? No, because as Xavier said, it doesn't have a power of 1. This is actually a quadratic function. Remember these 4 that we talked about earlier? So this one is an example of a quadratic function. Is this in the form mx plus b? Is the variable being multiplied by 3 or is it being divided by 3? So this is not a linear function. Any guesses as to what type of function this is? I don't expect anyone to know. This is a rational function. This is the third family of functions we will talk about in this course. Rational, rational function. When the variable's on the bottom, that's what makes it a rational function. What do you think the third one is? Square root of b plus 3. That's a radical function. So these three things are coming up in the future. What about 5 minus 3p? Is that a linear function? Doesn't look like mx plus b, though. What's 2 plus 3? What's 3 plus 2? So when you're adding stuff, doesn't matter the order in which you add them. So could I rewrite this problem as negative 3p plus 5? Now does it look like mx plus b? Can you rewrite this problem to look like mx plus b? That's why it's not linear. We always simplify before we classify. So if you can rewrite a problem, just rearrange terms or just simplify and get it to look like mx plus b, you have a linear function. If you cannot do that, then you don't have a linear function. Fair? 5c minus 4. Is that a linear function? Doesn't it look like mx plus b? I hear 2 people responding. I don't know what's happening with the rest of the class. Do we agree or disagree? You have a quiz on Monday on all this stuff, by the way, in case we're not awake yet. Does everyone understand what's going on? I am recording this too, so I'll post it on Canvas once it's done. Make sure you're concentrating and understanding what's happening instead of feverishly copying things down. 5c minus 4 does look like mx plus b. You have a number times a variable plus a number. Could be a minus number as well. Same thing. What about p of q, the last one on the bottom right? Could we manipulate it or massage it into mx plus b? 3q minus 5q is plus 4. Doesn't that look like mx plus b? So all 3 of these are examples of linear functions. These are not. Fair? Question so far. Do we know how to recognize a linear function in the wild? I don't want to go too far. Nope, not there. There. What is the equation of the green line? Equation. Equation. Not the slope, the equation of the green line. Because it's a what type of line? It's a horizontal line. Stop saying words. It's a horizontal line. What is the slope of all horizontal lines? Okay, someone say words. I didn't mean stop saying completely. 0. The slope of all horizontal lines is 0. So if you had to write y equals 3 in function notation, what would you write? Y is the same as what? F of x equals what? 3. So this is the equation of a line in slope-intercept form. This is the equation of the line in function notation. Is there anything different about them? Or is it just we're relabeling things we've done in the past? Fair? What is the equation? Not the slope, not the intercept. What is the equation of the red line? The one that's going up and down. X equals 4. Because it's a blank type of line. Blank lines go up and down. It's a vertical line. What is the slope of all vertical lines? What is the slope of all horizontal lines? So how can the slope of a vertical and a horizontal line be the same thing? They're not the same thing themselves. Is one a positive number? What is the if a line has a positive slope, which way does it lean? Does a vertical line lean anywhere? Then it can't be a positive number. It can't be a negative number. It can't be zero. What's left? The slope of all vertical lines is undefined. Remember the amount of extra effort it takes to just walk up a cliff while you're laying down? Could we define that amount of effort? No. What would be the equation of this in function notation? No. Where does zero come from? It has nothing to do with intercepts. Equations have nothing to do with intercepts. Y equals 6x plus 4. Change to f of x equals 6x plus 4. Did I do anything to the right-hand side? Y equals 3, change to f of x equals 3. Did I do anything to the 3? So what do you think x equals 4 would turn into? Sorry? F of x equals 4. Trick question. You should memorize every single exception to the rule. Exceptions are the things where people get caught. Every single linear function has to either be horizontal or tilted. Vertical lines are not linear functions. So what can you not write them in? You cannot write them in function notation because they're not functions. Vertical lines are not functions, therefore they cannot be written in function notation. It's an exception to the rule. They are straight lines, but they're not functions. You'll understand why later. Actually, everyone should have heard of this. Do we all know the vertical line test? Or have we heard of it before? No? Okay, ignore it for now. Just know and memorize that a vertical line, you can name it, you can find the slope of it, you can write the equation of it, but it is not a function. For the entire family of linear functions, the only exception is a vertical line. Everything else is a function in linear land except for vertical lines. Vertical lines are not functions. Are we okay with this? So x equals 4 is just x equals 4. There's nothing that I can do with it because it's a vertical line. Yes, no, maybe so. So I've given you a line here. I've given you the graph. Ignore the g and the h for now. Tell me the equation of this line with just y equals mx plus b. What would the equation be? Okay, let's make sure this makes sense. Is the y-intercept 1? Okay, plus b. That's easy. And then for slope, can we do a little rise over run dance? So if we start here, how high do I have to go? How many units? 1, 2. 2 units up. Then how far right do I have to go? 1, 2, 3, 4. So what's the slope? Rise over run is, which simplifies to, have we done this before? I give you a slope and a y-intercept and you come up with the equation. Instead of giving you the point and the y, or instead of giving you the same information as I did right here, instead of telling you what the slope is and what the y-intercept is, didn't I just give you a picture of it? I gave you a picture of a slope and a y-intercept. So it's the exact same information. Did you come up with the equation of it in slope-intercept form? You've done that before. Didn't I also ask you to, on Monday and Wednesday, write the equation where the independent variable is A and the dependent variable is B? What's the independent variable according to this picture? because that's on the blank axis. There are two axes. Pick one. H is on the blank axis. Which axis is H on? There is no X. What's the generic term for what you're thinking of? Starts with an H. It's on the horizontal axis. The independent variable is always the horizontal axis. So this X should get replaced with what letter? The Y should get replaced with what letter? G, that's the vertical axis. Why? Because G is the label for the vertical axis right here. The vertical axis is the dependent variable. That's the guy that sits by itself. Would we agree that this is something we've done before? I've asked you to come up with equations of lines with specific, with specific variables for independent and dependent variables. Yes, no, maybe so. New thing today, write this equation in function notation. Think about what variable goes where. There is no F, there is G and there's H. There are no F, there are no X's. G is the dependent, so it goes outside. H is the independent, goes inside, equals +1. Nothing changes on the right-hand side. Are we okay with this? Questions so far? Now, in the past, when I gave you equations or when you came up with equations, didn't you find x-intercepts and y-intercepts or p-intercepts and q-intercepts or b-intercepts and c-intercepts? You can do the exact same thing still. If I want to find the h-intercept, is that the horizontal or the vertical? Horizontal. So I want to know the location of this point. Where does the line cross the h-axis? To find the h-intercept, don't I set the vertical axis equal to 0? Or the dependent variable equal to 0? Isn't that what we're doing here? So 0 equals 2 over, oh, I'm sorry, 1/2. How would we solve this equation? We plugged in 0 for the quote-unquote y. Subtract 1. So -1 equals 1/2 h. It's already being divided by 2. Multiply by 2. So -2 equals 1h, which is just h, right? Okay, so give me the point now. Would it be -2 comma 0 or would it be 0 comma -2? Think before you answer. Because isn't h the horizontal or the quote-unquote x? So that always has to go first. If we just found the value of h, doesn't that have to go first? Also, h is the independent variable. What did we plug in for g? -2 comma 0. That's my point. Is any of this new, or is this literally just a relabeling job over what we've done before? Do we recognize it's all the same stuff? Three functions. If I said, look at R, look at the function named R. Which function do you look at? Is anyone looking at anything other than 5q minus 1? Why are we looking at that function? It's a dumb question, but humor me. There's a point I'm trying to make. When I say R, why are we all looking at R of q equals 5q minus 1? It's the only R there. Yes? Next question. Look at the function y. Which one are you looking at? No, I want look at the function y. I didn't say look at all the functions y. So which one are you looking at, Frank? So do you know which one you're looking at? Do you know which one I'm talking about? Do we understand why y equals mx plus b is bad notation the moment you advance out of just talking about one line? So oftentimes at this stage, people are like, who cares? I already have y equals mx plus b. I know how to deal with it. Why do we need this new relabeling nonsense? Because the moment you grow up and you start talking about two functions, does it not help to say one is p, the others are? Three functions. One is p, one's r, one is b. Do we know exactly which function we're talking about without naming the whole equation? Versus if I want you to look at this specific equation up top, I would have to say, oh, look at y equals 3q minus 4. Yes, no, maybe so. That's why it's beneficial to have individual labels and use function notation instead of just calling everything y and x. Other benefit. Do we remember a question where I said, I gave you an equation, something like this, and I said, or something like this, I mean. And the question was, find the value of the dependent variable when the independent variable value is 9. Do we remember doing stuff like that? That was a very wordy sentence, wasn't it? This is all I have to write to condense all of that nonsense into this. When I say find b of 9, what is the value of the independent variable? You should know where the independent variable lives. It lives inside parentheses. So when I say find b of 9, what I'm saying is I'm telling you that the independent value is 9. What am I asking for then? Which is the dependent variable's value, isn't it? Do we see how it condenses all the crap that we have to say into just, well, that little thing? So how would we do this? How would we find b of 9? Well, wherever we see a q, we replace it with 9. So negative 1 over 3 times 9 minus 4. 3 goes into 9 how many times? So this is really negative 3 minus 4, which is negative 7. So what is the value of the dependent variable when the independent variable is 9? Do we see how that's a long question that I didn't have to write down? Function notation allows us to be very, very concise and precise. It gets the point across much faster. What is this question? Give me the long way of saying this. What am I giving you? What am I asking for? So I gave you the value of the dependent variable, which is 29, and I'm asking you to find the value of the independent variable. It's a very, very wordy thing. Mathematicians don't like being wordy. We like very, very short, precise things. So what should I do to solve this problem? Would that make sense? I'm telling you that R is 29, and I want you to find what Q is. Replace R with 29 and solve for Q. Isn't this what we've done before? How would we solve this equation? What would be the point here? Something comma something. Think about what variable goes where. Who's the independent? Who's the dependent? Q is the independent because it's inside parentheses. R is the dependent. Didn't we just get Q was 6 and R was 29? So if you don't understand where the dependent is and where the independent is, you're going to mix up potentially your coordinates. You'll write them out of order. Are we okay with this so far? This is all review. All we're doing is just rebadging stuff. Oops. This is something else. Okay, let's talk about this guy. I'm going to speed rush through this. You should expect something like this on Monday. Not the exact same thing, but I'm not going to just ask you to find equations. It won't obviously be this long or this tedious, but I will ask you to basically understand what you're finding and then use it to find other things. So, something's happening with a food truck. You're selling burgers. Each burger costs $3 to make in raw materials, whatever goes into the burger. You sell it for $8. There's a parking pass that costs $10, and it's needed to sell, like to park your food truck and just sell burgers. So what if you park your truck and you realize you're out of gas and you can't turn on your grill? How many burgers are you going to sell that day? 0. Do you still have to pay the parking pass? Do you still have to pay for the parking pass? Yes, you still have to pay the $10. The commissary kitchen is where you do all your prep because there's not enough room on the food truck itself. So you go hire a commercial space. And because the owner's nice, they only make you pay $5 a day. So maybe you're out sick and you can't go sling burgers that day. Do you still have to pay the kitchen to occupy their space? Still have to pay that. What if you sell 1,000,000 burgers that day? Still have to pay the $5. So what here is a fixed cost, meaning I don't care how many burgers you sell, you still have to pay this. 10 and the 5, which is, does that make sense? Is there an element of something that is fixed and something that is changing? What here is going to change? The number of burgers being sold, but consequently how much money it's going to cost you, right? Because if I only sell one burger, if I only make one burger, what's the cost in raw materials? What if I sell or make 10 of them? So doesn't the cost change based on how many burgers I sell? If I sell one burger, how much money do I make? 8. What if I sell 10 of them? Do we see that this is variable, meaning it's going to change based on how many burgers I sell? The 10 and the 5, doesn't matter how many things I sell, that's fixed. Yes, no, maybe so. Okay. This remote, I am manufacturing these things and they cost $10 a pop. If I sell 5 of them, how much money do I make? $10 a pop. I sell 5. $50. How do we come up with 50? 10 times 5. Isn't that the price per unit? $10 times 5, the number of units sold. That's how you come up with a revenue function. Not just in my class, but in business. If you're selling something, you take the price of each thing you sell, you multiply it by how many times you sold it. That's your revenue. Very, very simple. So how much money are you going to make if you sell 22 burgers? What's the price per burger? $8. So how much money? $176. That works. How did we come up with that? Does that seem reasonable? 22 number of burgers times 8, the price per burger, tells you $176. Fair? I'm going to start picking up speed. How much money do you make if you sell 48 burgers? 384. Presumably 48 times 8 is 384. What if I don't know how many burgers I'm going to sell? So, but I say it's going to be X burgers. 3X. That doesn't seem right. I'm selling them for $8. Are we okay with that? This is my revenue function. Revenue function is you tell me how many burgers you want me to sell, and I can tell you how much money you'll make. 8 times whatever number you give me. Yes, no? Cost function. Cost is how much money you have to put out, you have to shell out from your pocket to keep the lights on and to sell burgers. There's always two types of cost. One is a fixed cost, meaning the cost of running this college means you got to turn the lights on, you got to turn the air conditioning on, you got to pay someone to patrol the campus to make sure it's safe. Those are fixed costs, right? Whether there's 10 people on campus or there's 1,000 people on campus, this building has to be air conditioned. Fixed cost. The college has to pay that. Maybe it's $10,000 per day. You just have to pay that regardless of how many people there are. Cost per unit is maybe just baseline air conditioning is $10,000. But then what happens when more people show up? Doesn't the air conditioning cost go up? Because you got to cool it faster. That's variable cost. So if there's only me in here with one other person, the variable cost is going to be low because you're only cooling it ever so slightly. What happens if there's 100 people in each room? Variable cost is going to shoot up because now you got to run the AC really, really hard. So what is your fixed cost in this problem? $15. What is the total cost if you prepare 50 burgers? $150. That doesn't seem right. Because the total cost is not just $3 per burger, it's $3 per burger plus your fixed cost that you got to pay regardless of how many burgers you sell. Do we understand why it's 165? What about 40 burgers? 40 times 3 is 120 plus the $15 that we have to shell out regardless is 135. So what's the cost function then? 3x plus 15. Isn't this just slope intercept form? And isn't this your B, the fixed cost? So moving forward, the initial investment, the fixed cost, the initial value. How many clickers were there at the beginning? Wasn't that the y-intercept of that line? 4t plus 1? Do we understand the things that don't change throughout the problem always become the y-intercept or your fixed cost or your initial value? And then what keeps changing? The number of burgers sold. So that's your variable. That's X. I don't know how many burgers I'm going to sell. Let's call it X. What's the slope? What's the cost per burger? Cost per burger, cost per burger. That's my slope. 4 clickers per minute, 5 clickers per minute. Do we recognize the per word? Miles per hour. Isn't that always a unit of slope or rate of change? Cost per unit. That's the slope. Are we okay with this? Okay, a function is basically it takes an input, does something to it, and then it gives you an output. That's all a function is. So you have a revenue function R of X, you have a cost function C of X. Well, read these, tell me which ones to check. What is it? The first one, R is the dependent. Is it on the outside? So that works, I agree. The thing on the outside is the dependent variable. The thing on the inside is the... So is there another thing I could check? X is the independent because it's on the inside. And C, isn't C on the outside again? So C is the dependent variable. Easy? Okay. Now think about pictures or graphs. Where do we place the independent variable? Always. The horizontal axis. Where do we place the dependent variable? Always. The vertical axis. Let's start moving away from, I know what you guys mean by X and Y. Let's start moving away from X's and Y's and move towards general terms like horizontal axis and vertical axis. Because you don't have to have X's and Y's. You could have P's and Q's and G's and H's. I don't want people getting things marked wrong because you used X's and Y's again. You got to use the variables that I give you or the question gives you. So which of these would need to be marked? One would label the horizontal axis as X, which makes sense because X is the independent variable, and the vertical axis as R. I agree, because that's the dependent variable. That seems reasonable too for this guy. Any others? Just those two? I feel like I'm having a conversation with two people. Does anyone have questions? You're taking a quiz on this on Monday. You're not going to figure this out independently. That's not me being a jerk. That's just me saying this is very, very dense and very minute, small moving parts. If you have a question, please ask. Okay, for R of X equals 8X and C of X equals this function, which of the following is true? X represents what? Number of burgers, the amounts of burgers sold or made. R represents what? The money, the dollars. You sell X burgers, how much money do you make? So if I have R of 50, am I replacing R with 50 or am I replacing X with 50? So 50 represents dollars or burgers? And we all make those connections. All of that is written in this very, very short form, shorthand notation. So does R of 50 represent the number of burgers sold for 50 bucks? Is X dollars or burgers? R of 50 would represent the what? It would be the dollars made from selling 50 burgers, right? Do we see that sentence somewhere? It's this guy. R of 50 represents the total revenue from selling 50 burgers. What do you think C of 50 means? Not per burger, because it's C of X or C of 50. Total cost of 50 burgers. What should it say if you wanted the cost of a burger? C of X would be the cost of an unknown number of burgers. I don't know what. C of 1 would be the cost of one burger. What would be C of 7? Cost of prepping 7 burgers. Are we okay with that? So C of 50 represents the total cost of prepping 50 burgers, or does it represent the number of burgers prepped for 50 bucks? C is the cost. It's not the number of burgers. So it cannot represent the number of burgers prepped for $50. 50 represents what? Number of burgers. So C of 50 represents what? The cost, not the number of burgers. C of 50 is how much money do you have to shell out to manufacture or prep 50 burgers? Questions? Do we understand how to read these? Okay. Think. Thoughts? I don't know which one you're talking about. 1, 2, 3, or 4. R of 50 equals 400 represents a revenue of $400 from selling 50 burgers. Does that seem reasonable? I agree. Any others, or is that the only one? Sorry? The fourth one, C of 50 equals 165 represents a cost of $165 for prepping 50 burgers. I agree. Those are the only two. When finding R of 36, ignore the sentences. What does 36 represent? Dependent or independent variable? Independent. And what is normally here instead of the 36? So what are we doing when we find R of 36? Think about what we did when we found B of 9. I can't hear you. You're still speaking at the same volume. Correct. So you replace X with 36 and you solve for, okay, find that answer. Well, that's easy. You replace all the X's in R with 36 and you find R. What is this guy saying? R is 36 in this case. And what am I asking you to find? Which means I'm telling you that the revenue is 36 bucks. And I'm asking you, how many burgers would you have to sell to make $36? So what would we do here? We set R of X equal to, okay, what do you think it is? Do you agree or disagree? Excellent. Okay. Now tell me what RF36 actually is. Eight X, $8 per burger. R of X, the function is R of X equals 8X. 288, I hear. I'm guessing that's just 36 times 8, which is R of X. So R of X is 8 times X. So that's what R of 36 is. What is the cost of making 32 burgers? 111, you said? 15 plus 3 times 32, right? 15 plus 3x was the cost function. Yes, no, maybe so. Are we together? 9 is 30. What does that mean? Oh, the answer to question 9, you're saying? Okay, so if R of X is equal to 240, that means what am I looking for? What am I looking for? For how much money? So if I make $240 in revenue, how many burgers am I selling? So you're saying it's 30? That seems right. Does everyone know how we're coming up with these numbers? Okay, if the cost is 153 bucks, what can you find? What can we work our ways back to? 15 plus 3x, or 3x plus 15. Do you want to write it down? 15, c of x equals 15 plus 3x. That's the cost function, or 3x plus 15, however you want to say it. C of x equals 15 plus 3x. That was the cost function. Do we agree, disagree? We have a cost. We need to back into how many burgers were sold for that cost, or prepped for that cost, I'm sorry. So we prepped 46 burgers. Hooray. Everyone know how to get there? Okay, now we make some money. If I manufacture an iPhone for $500 and I sell it for 800, am I making profit? How much? $300. How'd you come up with that number? I can't hear you. We could do that. How do we do it more directly? If I manufacture for 500, that's my cost, isn't it? And then if I sell it for 800, isn't that my revenue? Revenue minus cost. What if I manufacture the phone for 500 and I sell it for 200? Negative 300 is my profit. So I do get profit. It's just negative. It means I lost money. I lost $300. Fair? Here's how you come up with your profit function. So do we know that the revenue is 8x and the cost is 15 plus 3x, or 3x plus 15, whichever one you want to see it? So if I do revenue minus cost, you have to do revenue first, 8x, and then the thing that everyone makes a mistake on is they forget to use parentheses for the cost function. If you don't have parentheses, you will not need to distribute the negative. If you forget to distribute the negative, what is this 3x going to stay? Positive 3x, and then the whole thing is wrong. So when you subtract functions, you must put the guy on the right in parentheses to make sure you distribute the negative to all the terms. So when we distribute this negative inside, we get negative times 15 is negative 15. Negative times 3x is negative 3x. And now what is 8x minus 3x? 5x minus 15 just comes along for the right. So what is our profit function then? 5x minus 15. Okay, so which of these can be used to find the profit from selling 42 burgers? Well, that makes sense. Isn't that the revenue from selling 42 burgers minus the cost of selling 42 burgers? And then what, well, couldn't we also just say what's the plug 42 into the profit function and tell me what we get? So both of these are the exact same thing. Okay, if the revenue from selling 44 burgers is that, and the cost is that, how would we find the profit from selling the same number of burgers? Revenue minus cost. So what do we get? 205? Hey, so 352 minus 147 gives you 205. If I tell you the revenue function and I tell you the cost function, what is the profit function? That's what I just showed you right here. So here's how you'd come up with that. Okay, so now that you have a profit function, how would you find the profit from selling 26 burgers? Do we see that this is everything we've done before? We've just dressed it up with a story about a food truck. Haven't we come up with equations in the past and then plugged in an X value to find the Y value? We're doing the exact same thing here. Instead of, well, X is still X, but the Y value is the profit function, P. So if we plug 26 in here, what do we get? What's 5 times 26 minus 15? 115? Hooray. What is the profit from selling 20 burgers? What should we do? No, because P of X represents dollars. P of X is the profit. Is this the profit or is this burgers? So you're not plugging in 20 for P of X. What are we doing? You could do that, or why not use this shiny new toy we just got, which is the profit function? No, he said replace 20 for P of X. Plug that in for P of X means take P of X away and put 20 instead of it. That's not what you said. What you said was plug 20 in for P of X. What should you have said? Correct. Do we understand the difference between the two statements? You're replacing X with 20 in the P of X function versus replacing P of X with 20. In fact, that's going to happen in the very next problem. So if we plug 20 in for X in this, what do we get? Correct. Now think about how that is different from this question. If $125 of profit was made, how many burgers were sold? So what am I giving you now? Which is represented by, now say the thing you said earlier. Do we understand that? That's not the same as replace X with 125. That's saying take P of X, replace it with 125 because P of X represents the profit. Fair? Okay, so if we replace P of X, which is this guy, with 125, we'll have 125 equals 5X minus 15. Sorry? Is that what you're saying the answer is? Do we all know how to solve that equation? 125 equals 5X minus 15? It's exactly the same as that, but instead of setting the cost equal to 153, you would set the profit equal to 125. Yes, no, maybe so. Oh, that doesn't work. Maybe we should write it down on a board somewhere. Maybe we should write it down on a board somewhere. Ah, 28. Yay. Yes, no? Okay. What if $105 of profit was made? How would you get to the cost and revenue from there? I'm telling you how much profit was made. How do you get from the profit all the way to cost and revenue? Because that's how much the profit is, right? What could you find from that if we set 105 equal to the profit function, which represents the, okay, someone else. If we have the number of burgers sold, then how could we get the cost from it? I'm curious, does anyone go home and say, I want to take a hammer and hit my knees with it? Genuine question. Does anyone go home and do that? Or like you're sitting in your car driving wherever you're going and say, let me just grab a hammer or let me just take my foot and ram it into a door. Does anyone do that? Because that would be what? That would be crazy. You don't want to harm yourself, right? That would be absurd. But yet we just hold our tongue in a math class and don't recognize the harm. You're literally, not literally, you're figuratively hammering your knee with a hammer by staying quiet. If you don't speak, I can't fix what's in your head if it's wrong. And if it's correct, I can confirm and give you confidence. I know you know the answer. Where the 28 comes from. Wait, what? No, that question's over. We're not talking about 28 anymore. Okay, someone solve this equation for x. Plug 105 into the profit or replace P of x with 105. Whoa, 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 whoa. No, still bigger whoa. Yes. Double fisting hammers here. Triple fisting hammers. Free hammers for everyone. Okay, hold on. Patience. What does x equals 24 represent? What has Xavier found for us eventually? The number of burgers sold to do what? No. To what? If we have a $105 profit, we must have sold 24 burgers. That means 24 burgers were sold to make a profit of 105. Fair? Okay, now back to Indiana. What were you saying? Into which x? We have three functions now. What are you trying to find? So which function should you plug 24 into? Okay. Which one do you want to plug it into first? Okay. What's the revenue function? What is the revenue function? 8x. 8x is the revenue function. So if I'm selling 24 burgers, how much money am I making? What's the revenue? 192. Okay. So what's the cost then for selling 24 burgers? Oops. Yes, no, maybe so. What's the difference between this revenue and this cost? What's 192 minus 87? Hey, it's almost like that was the profit we made. Yes, no? Okay. This should look very familiar. What are the three ways we graph straight lines? We can find the intercepts. We can use rise over run and a y-intercept, or you can just find 2 points. So we need to graph 8x. I just need 2 points here. Nothing special about them. So give me 2 points that lie on this line. If I plug in 1 for x, I get 8 for r. That's fine. Can't be 2 and 8. If I plug in 2, I'm not going to get 8 again. If I plug in 2 here, what do I get? 2, 4. Plug 2 in here. 2 for x. 8 times 2 is. Hooray! So this is the graph of what? That's my revenue function. Number go up. What happens the more burgers I sell? I make more money, which hopefully makes sense. Yes? Okay, this is my cost function, and I want it by finding the y-intercept and some other point. So what's the y-intercept here? Something comma something. Can't be 1. Y-intercept is found by setting x equal to 0 and 0 comma 15. Isn't the b value the y-intercept? So that's the y-intercept. I need another point found using the slope. What's the slope of this line? So from here, go up how much? And go right how much? So if you start at 0, 15 and you go up by 3, what's your new y coordinate? From 15, you're going up 3, 18. And from 0, you're going right by 1, 118. Hooray! Red line is the cost function. What's the profit function? And I need an x-intercept and a second point besides the y-intercept. The x-intercept cannot start with a 0. Negative 15, 0, because we're setting 0 for y. That is incorrect. If you replace this with 0, how would you solve this equation for x? Add 15, divide by 3. What do you get? Divide by 5. Freudian slip, 3. And I need a point that's not the y-intercept. So give me one other point on this line. Plug in any number. I'll give you the number. Plug in 2. 10 minus 15 is negative 5. Excellent. There's my profit function. Now here's the analysis. When are you losing money? You can graph stuff, but do you know what you graph? Do you understand what you graph? So where in this picture are you losing money? Uh, okay, ignore the green line. Look here. What if you manufacture or sell 0 burgers? What's your cost? Your cost is 15 bucks. You got to pay for the kitchen. You got to pay for parking. That's the red function. If you sell 0 burgers, how much do you still have to pay? 15 bucks. So if you sell nothing, are you losing money?
Yes.
Yes, because your revenue is, no, your revenue is 8x. 8 times 0 is 0. Isn't your revenue 0, 0 right here? This is going to be on your quiz. Give me 30 seconds. If you sell 1 burger, how much is your cost? 3 times 1 plus 15 is 18 bucks. What's your revenue if you sell 1 burger? Are you losing money? What happens if you sell 2 burgers? What's your revenue? How much is your cost? 3 times 2 is plus 15. So it costs you 21, you sell for 16. Are you making money? 3 burgers, what's your revenue? 24, what's your cost? 3 times 3 is 9. 9 plus 15 is. So what happens when you sell 3 burgers? That's the break-even point. Does that have anything to do with the graph?
Yeah.
Yes, because that's where both lines do what? What's the profit when you sell 3 burgers? So could you have seen that from the profit graph? What's your break-even point? Isn't that when the profit is 0? When is the profit more than 0? The moment you sell how many? So did you have to do all that mathematically, or could you just have looked at the profit function and said, where do I cross the x-axis? Does that make sense? So please make sure you're not just saying, oh, I know how to graph equations, but I don't know what I'm doing once I've graphed them. Like, what's the interpretation? You need to know how to graph them, and you also need to know how to read them. Like, once you have a picture, what does that mean? Yes, no? Quiz on Monday at some point of time, either today or tomorrow. I'll publish some practice problems. Please do not assume that the quiz will look exactly like them. It'll have the same type of questions, but don't expect it to be the same. Questions? Can't hear you. Yes. Any other questions? All right, I'll see you on Monday.